Hello friends and my dear students, I welcome you all to my channel. If you are new to my channel or not yet subscribed, then I will highly suggest and request you to please support me by subscribing to my channel, and also please do not forget to press the bell icon so that you will be notified by my future videos. Uh, when you support me by subscribing to my channel, that way I get motivated to come up with this kind of videos on regular basis, and also that will help me grow my channel. So please, if you are not yet subscribed and if you are watching my videos on regular basis and my videos are beneficial to you, then please support me by subscribing to my channel, and also like my videos, share them with your friends, and also do not forget to press the bell icon. Thank you. This video is part of the playlist CBSE Mathematics Class 7 following the textbook of author R.S. Aggarwal. This is class number 4 on the chapter Exponents, where I am discussing about the laws of exponents. This is part 3 on the subtopic of laws of exponents. In this video, I will do some word problems based on the laws of exponents. I will solve few problems from the exercise 5A from the textbook of author R.S. Aggarwal, and will do some miscellaneous problem. If you have not watched the previous 3 classes videos, then I highly suggest that you please watch them first to get to have the continuity of your study on the chapter of exponents, and then you can continue to watch this video on the word problems. So let's get started. Okay, so as usual, I have my notes about on the exponents and the laws of exponents on the left hand side, and on the right hand side I will discuss any concepts required and will solve the problems. Okay, so in this video I will solve few problems, word problems, where a puzzle or a problem will be given in words, and you have to translate, map the problem into a mathematical problem involving the exponents of numbers. That means the numbers in exponential forms, powers, and also the using the laws of exponents we will have to solve the problem. Okay, so let's start solving the problem. This is exercise 5A, problem number 11 from the textbook. It says, by what number should minus 1 to the power minus 1 be multiplied so that the product is 8 to the power minus 1. So if we assume that the number that should be multiplied to minus 1 to the power minus 1 be x. So let the number be x. So from the given problem, it is asking that if you multiply minus 1 whole to the power minus 1 in multiplied by x, it should give 8 whole to the power minus 1. So this is now the mathematical statement, puzzle statement, that we have translated from the given word problem. Now we have to solve this from this equation. We have to solve x, and we know that from this we know that x will be equal to 8 to the power minus 1 divided by minus 5 raised to the power minus 1. Now, so this is a division of two exponents. By exponents I mean a number in the exponential form. So in one of my previous videos I have already discussed about division and multiplication of two exponents. So exponents, that is, we have discussed about the law a by b to the power m divided by a, not a by b. Okay, so this law will not be applicable here because we can see the base are different. The bases are 8 and minus 5, so they are different, but the but the powers are same. This is a relatively simple problem because power of minus 1 is nothing but reciprocal. So this will be 8 to the power minus 1 means reciprocal of 8, which is 1 by 8, and divided by minus 1 minus 5 raised to the power minus 1 means the reciprocal of minus 5, that is 1 by minus 5. Now again, we do not keep negative denominator, so we will convert the second rational number 1 by minus 5 to have a positive denominator. So this becomes 1 by 8 divided by minus 1 by 5, and we know that division of 2, now we have a division of two rational numbers. We know that when we divide by a rational number, it is equivalent to the multiplication of the reciprocal of the rational number. So this will be 1 by 8 multiplied by the reciprocal of minus 1 by 5, that is 5 by minus 1. So this is 5 divided by 8 into minus 1, 8 into minus 1, this is 5 by minus 8, and again we do not keep negative denominators, so to make it positive it becomes minus 5 by 8. Now you might be thinking that this is a long process. Yes, this is a long process, and there is a shorter process to, we can do it quickly. See that the x was originally we had to solve x, where x was 8 reciprocal of 8 divided by reciprocal of minus 5. Now when we divide by a number, when we have a divided by b, this is equals to a multiplied by the reciprocal of b, which is b to the power minus 1. We know this. Now so okay, and if we have to divide, so this is this, we know. What if we have something like a divided by b to the power minus 1? So if there was, minus 1, if b was raised to the power minus 1, so in that case it would be a multiplied by the reciprocal of b. The reciprocal of b to the power minus 1 is b. So in this case this would be simply b. So 8 reciprocal of 8 divided by reciprocal of minus 5, we could have directly from here, we could have written 8 minus 1 multiplied by minus 5. We could have written this. This would have saved a little bit time, but it's okay, no problem. You can always try to solve this problem step by step using the fundamental laws of exponents, and don't try to be over smart. Use the fundamental laws, go one step ahead, and then slowly solve the problem. In that way you won't make any mistake. Okay, so the answer is x is minus 5 by 8. So you have to multiply minus 5, reciprocal of minus 5, with minus 5 by 8, so that it gives the product as 8 raised to the power minus 1. Okay. Question number 13 says, by what number should minus 30 raised to the power minus 1, that is reciprocal of minus 30, be divided to get reciprocal of 6? Power minus 1 means, always remember, it's a reciprocal of the base. So let's say the number, let the required number that we have to find be x. Let the number be x. This is how we solve this kind of problem. Let the number be x. Now we have to translate the given problem statement into a mathematical statement. So we will have, if we divide minus 30 to the power minus 1 divided by x, we should get 6 to the power minus 1. Now, this implies from this mathematical statement we know that x equals minus 30 to the power minus 1 divided by 6 to the power minus 1. So again we see that it's a division of two exponents, and the divisor is a reciprocal. The divisor is 6 to the power minus 1, which means a reciprocal. So this will directly, using the concept that I discussed in the previous problem, that this arrow from here we can directly write it as 8 inverse multiplied by minus 5. Similarly, we can write here this is nothing but minus 30 to the power minus 1 multiplied by 6. So the idea is that you have any number, if you divide by another number, by the reciprocal of another number, this is nothing but a multiplied by b. This is a short, not a trick, but you can save time. So this is this. Now we know that what is minus 30 to the power minus 1? It's a reciprocal of minus 30, that is, and minus 30 is the minus 30 by 1. Okay, let me write it. The minus 30 is minus 30 by 1 to the power minus 1 into 6. Now the reciprocal of minus 30 by 1 is nothing but 1 by minus 30 into 6. Again my pen is working very slow, something wrong with my machine, I don't know, it's giving a lot of trouble. Now this is, we have now 1 by minus 30 multiplied by 6. The first rational number is having a negative denominator, we would like to convert it to a positive denominator, so it becomes minus 1 by 30 multiplied by 6. 6 cancels 30 with 5, so the answer is minus 1 by 5. This is x. We have found x, the number that should be dividing the number minus 30 to the power minus 1 to give 6 to the power minus 1. While I am solving, you can pause the video and take screenshot for your reference. Okay, question number 12 says, by what number should 3 to the power minus 3 be multiplied to obtain 4? So let the number be, let the number be x. Okay, so according to the problem statement, this means 3 to the power 3 when multiplied with x gives 4. So this implies, from here we can solve x, this implies x equals to 4 divided by 3 to the power minus 3. Let me quickly check, did I, so that, okay, so we have this, x equals 4 divided by 3 to the power minus 3. Again, see, the divisor here is 3 to the power minus 3, so we can write it as 4 multiplied by 3 to the power 3. Again, okay, so as a side note, this is an important trick you can always apply to save time. When you have something like a divided by b to the power minus m, if you have this, where m is a positive integer of course and b is of course a non-zero, a and b are non-zero integer. If you have this, this will be a multiplied by b to the power m. Let me show you how this is coming. So we know that uh, a divided by some number is nothing but a multiplied by the reciprocal of that number. So in this case, a divided by b to the power minus m will be a multiplied by the reciprocal of b to the power minus m, the reciprocal of b to the power minus m. This. Now this is equals to a multiplied by, so we have b to the power minus m and that again to the power minus 1, and we know that in that from the laws on the left hand side, if you see, we can apply the law number 5, the law number 9. This will be b to the power minus m multiplied by minus 1. This is nothing but a multiplied by b to the power m. So this is how it is coming. Okay. So now we have 4 into 3 cube. So this is okay. So 4 and 3 cube is 27, and this is 28 and 11. So this is the number that we have to multiply with 3 to the power minus 3 to give 4. Okay. Now we have 1, 2, 3, 4 and 5 miscellaneous problems. These are little harder problems. I'm not sure whether I will be able to solve it, but I will give a try. Let's see. Okay. So while I'm solving, you can pause the video and take a screenshot of the solution for your reference. So miscellaneous problem number 1, what should be multiplied to? We have a product of 3 factors, where first is an exponential form, so that the product is equal to 3600. So what should be multiplied to? Okay, so as usual, let the number be x. So as per the problem statement, we should have 2 cube multiplied by 3 multiplied by 5 multiplied by x should be equal to 3600. Now from here, please do not, if you, the one straightforward method is that you will say that this means x equals 3600 divided by 2 cube into 3 into 5, and you will simplify this. This is fine, but this will take longer time. This will take longer time. This method is fine, but so now you have to find the denominator and then convert this expression to a rational form and do cancellation. It will take more time. The better way is that you express the number on the right hand side 3600 as a factor of prime numbers. As you can see on the left hand side, all the factors have base. I mean 3, it can be written as 3 to the power 1, 5 can be written as 5 to the power 1, all have base prime numbers. So somehow you have to factorize 3600 as a factor, do prime factorization, and you will see from there that some prime numbers will be repeated, so you will get an exponent, and from there you can easily find out what x will be. So let's see, if you do factorization of 3600, if you divide by 2, we get 1800, fine, divided by 2 again 900, divided by 2 again 450, okay, divided, if you divide by again 250, you divided by again 2 cube, okay, let's see, 125, now I have to divide by 5, this is 25, again by 5, this is 5, and again by 5, this is 1. So 366 is nothing but how many 2's are there? 1, 2, 3, 4, 5. So multiplication of 5 2's, so it becomes 2 to the power 5 multiplied by 5 is how many times? 3 times. So 5 is 3 times. Okay. So we have this. I am rubbing this part. Okay. So how do we? So we have expressed 3600 as 2 to the power 5 and multiplied by 5 cube. Did I do something wrong? I should get a factor of 3. Let me check. 3600 2 18. Okay, 00 2 900 2 450 2 2 no, I did it wrong. Okay, I did it wrong. I'm prone to make mistakes, do calculation mistakes. So please watch that out if I'm doing any mistakes or not, and you can let me know in the comment section. I will appreciate that. Now this will be 225. Now I can divide it by 3. This is 75, and now I can divide it by 5. This is 15. No. 2 450. Okay. Let's see. 5 is 15, and 5 is 3, and 3 is 1. Okay. So the prime factorization of 3600 becomes 2 is how many times? 4 times. So 2 is 4 times. Okay. 2 is 4 times. 5 is 2 times. 5 is 2 times. 3 is 2 times. 3 is 2 times. Okay. So this is the prime factorization of 3600. Now on the left hand side, we have 2 cube into 3 into 5. So the trick is somehow you have to, from the right hand side, you have to take out 2 cube into 3 into 5 and leave the rest of the factor as it is, and that rest of the factor should be x. I mean, from 2 to the power 4 multiplied by, so we have expressed 3600 as 2 to the power 4 multiplied by 5 square multiplied by 3 square. From here I want to take out all the factors that are given on the left, that is 2 cube. Okay, 2 cube, and I am the remaining factor I am writing in bracket. So 2 cube I have taken out from 2 to the power 4, so I have left with 1 2. Okay, now 5 square, but on the left hand side there is 5 only, so I will take 5, let 5 be, and another 5 in the bracket. Now on the left hand side there is 3, but on the right hand side we have 3 square, so there will be 3. So this becomes now 2 cube into 3 into 5, and if I keep all the numbers inside the bracket together, we have 2 into 5 into 3. This is equals 2 cube into 3 into 5 into 5 into 10 into 3 is 30. We have this. Now if you compare the left hand side with the right hand side, clearly x is 30. X is 30. So the number that should be multiplied to 2 cube into 3 into 5 to give 3600 is 30. The answer is 30. So this was the trick. I hope you understood the trick. So if you have this kind of problem, you on the left hand side you will have some factors given, some given numbers with some powers, and the right hand side you will given a fixed number, an integer. You will have to express that integer, do prime factorization, and then from that prime factorization you have to take out all the factors that are given on the left hand side, and the remaining factors should be the unknown number, that is x. I hope it's clear. If it's not clear, then please do let me know in the comment section. I will highly appreciate that, and I will try my best to address your query. Okay, let's do question number 2. By what number should this be divided so that the quotient is equal to 11025? It's similar to question number 1, but now we have a division. Okay, so let the number be x. So we have, this implies if the number is x, then we should have 3 cube multiplied by 5 to the power 4 multiplied by 7 to the power 3 divided by x should give 1 1 0 2 5. So the main concept is to express 11025 as a product of primes, that is we have to find its prime factors. So let's find out the prime factors of 11025. Let's divide by 5. We get 10 2 0 5. Okay, now we can again divide by 5 and see 4 4 1. Okay, now will it divide by 3? Yes, it will. So 3 1 4 7. It will again divide by am I right? 3 1. Okay, it will again divide by 3. It will be 4 and 9. So now we have 7 7 and 7 and 1. So 11025, his prime factorization is, we have two 5s, so 5 square. We have how many 3s? 3 square. 3 square, and we have 5 square multiplied by 7 square. So now since okay, now in this problem it is better, we can see now if this is so, then this implies definitely x will be 3 cube into 5 to the power 4 into 7 to the power 3 divided by 3 square multiplied by 5 square multiplied by 7 square. Now this kind of simplification is easy because we see that the numerator, both the numerator and the denominator all have products of exponents, and we have the similar bases in all the products. The numerator has the bases 3, 5 and 7. Also the denominator have the bases 3, 5 and 7 and some powers. So it is now simple. We merge the exponents with the same base, that is 3 cube. We have 3 cube divided by 3 square, which is nothing but 3 to the power 3 minus 2. So this becomes 3 to the power 3 minus 2 multiplied by we have 5 to the power 4, and in the denominator we have 5 square. So this will be 5 to the power 4 minus 2, and also for 7 we have 7 to the power 3 minus 2. So this is 3 to the power 1 multiplied by 5 square multiplied by 7. So this is 3 multiplied by 25 multiplied by 7. This is 25 multiplied by 21. Okay, so this is how much? 25 25 multiplied by 21 is 25, and this is 50, so 525. So this is 525. So the answer is 525. This is the number that we should divide the given number. 3 cube multiplied by 4 cube, 4 to the power 4 multiplied by 7 cube should be divided by 525 to give 11025. Okay. I hope I am right. If I am wrong anywhere in doing some calculation mistake, please do let me know in the comment section. I will appreciate that. Question number 3, he says that find the two positive integers such that if 1998, 1998 is written as a product of these integers, their difference is as small as possible. So if the two integers are x and y, or x and y, the problem statement is that if the two integers are x and y, it is given that x multiplied by y is equal to 1998, but the difference is, this should be minimum. This should be minimum. The difference is as small as possible. So we have to find two factors. Basically, we have to find, we have to factorize. We have to find two factors of 1998 so that their product is 1998, but those two numbers, those two factors are close enough so that the difference is minimum. So let's see. Let's see the factors of 1998. What are its prime factors? So if you divide by 2, we have 9, 9, 9. So now if you divide by 3, this is 3, 3, 3. And if you again divide by 3, this is 1, 1, 1. 1, 1, 1. Okay. Okay. So if we again divide by 3, we have 3 3s are 9, 7. Okay. Now we have no more factorization. So we see that 1998 equals 2 multiplied by 3 multiplied by 3 multiplied by 3 multiplied by 37. Now if we consider 37 as one number, so we have to find out two factors. Somehow we have to find out two factors so that the product is 1998, but the difference is minimum. Now if we consider 37 as one number, and what is this? This is 6, 18 and 18 and 54. This is 54. Now 54 multiplied by 37 is definitely 1998, but its difference is whatever. Is there any other factor that is there any other two ways we can find two factors that their product will be 1998 and the difference is minimum? Now see, there cannot be, I cannot factorize 37 anymore further. Now if I so this is, I think, the best way to find the two integers, that is the two factors will be 54 and 37. So certainly 54 multiplied by 37 is definitely 1998, and also 54 minus 37 is 7 and 1. Now how am I saying that these are the best two integers? These are the best factors. These are the factors whose difference will be minimum, and their product is 1998. Because if you consider, you have to make the two factors very close enough. Now, if you consider 37, if you multiply, if you consider a factor which is 37 multiplied by any other number, then the difference will be keep on increasing. So I think this is the best way, best two factors such that the difference is minimum and their product is 1998. So the numbers are 54 and 17. So the main idea was to factorize, to do prime factorization of the number 1998 and find two factors, create two factors so that the difference is minimum but the product is the number 1998. Okay. Let's do problem number 4. It says that the volume of a solid dice is equal to the cube of its age. If the volume of the dice is 125 cubic centimeter, find the length of the age of the dice in centimeter. Dice means this kind of thing. It's a solid cube kind of thing. I'm showing it transparent, but it is solid. So we have how many faces? We have 1, 2, 3, 4, 1, 2, 3, 4, 5, 6. There are 6 faces, and these are the age. So these are the age. These are the ages. So it's saying that the volume. Let's say the volume. Let V be the volume. Let S, not S, let L be length of an edge. Now it says that the volume of a solid dice is equal to cube of its age. So as per the given problem, we should have volume equals the cube of the age, that is L to the power 3. Now the volume is also given as 125 cubic centimeter, 175. So we have L cube equals to 125. From there we have to find what is L. Now obviously we have to express 125 as in exponential form, so that the power exponent is 3. Only then we can find L. So we know that 125 is 5 into 5 into 5. So this is 5 cube. So this implies L equals to 5 centimeter. Now the concept that we used is one law that I have in the notes, and that is the law number 7. If you can see on the notes, if you have something like in the notes, it is given in the with rational numbers, but for any number, if you have a same equal a to the power m equals to b to the power m, so we are equating two exponents where the exponent power is same. This will imply that a equals b. So this is the concept we applied in this problem to solve. So the length of the age of the dice is 5 centimeter. Okay. Question number 5 says, how many natural numbers are there from 10 square to 20 square? So how many natural numbers are there from 10 square to 20 square? So it is asking, starting from 10 square, we will have something. 10 square is 100. So 10 square is 100. So we will have 100, 1, 100, 102, and so on and so on. The last number is 20 square. 20 square. 20 square is what? This is 20 square is 400. 20 square is 400. So how many numbers, okay, so this is 100, 101, 102, like this 400. So how many natural numbers are there from 100 to 400? Now there is a formula that how many numbers, how many not natural numbers, but how many integers number, this is a side formula, number of integers from A to B, from A to B, A and B are integers, number of integers from A to B is equal to B minus A plus 1. And if it was, whereas this is this, you should remember this formula, number of integers. The pen is giving a lot of problem, it is working very slow. I don't know whether it's due to the slow machine or what. It has only 4 GB RAM and this writing software is running and OBS is running, I have no idea. Anyway, so number of integers between A, the pen is not writing at all. The number of integers between A and B is B minus A minus 1. Now what is the difference? The first one is the number of integers from A to B, that is, it includes starting from A and ending to B, it includes A and B. In that case, the number of integers from A to B is B minus A plus 1, whereas the second one is number of integers between A and B, it does not include A and B. So starting from A plus 1 to B minus 1, then the formula is B minus A minus 1. So in this case, we have to find number of integers from 100 to 400. So the answer is 400 minus 100 plus 1. This is 300 plus 1. This is 301. This is the answer. So these 301 natural numbers are there from 10 square to 20 square. So that brings to the end of the set of questions I wanted to solve in this video. These are all word problems, and there is a few more topics left on the chapter exponents. The next topics will be expressing large numbers as exponents. Then you have large numbers in standard form, and then we have square root, and probably cube root. I have to check the textbook. And once those concepts are done and problems on those concepts are done, I have to solve more problems on simplification problems, simplification of expressions with exponents, powers, and more of solving unknown. In the last video, the last video was based on simplification and solving an unknown. I mean unknown in the power. So these kind of problems could be tough and could be tricky. So it's better we solve a more set of problems so that we have a good practice and we have a good understanding of the concept on laws of exponents and how to apply them in the given problem. So there will be a couple of videos more, and once, so the idea is next I will cover the next topic, that is expressing large numbers as exponents, then large numbers in standard form, then square root, cube root, and then possibly I will solve the MCQ objective questions given at the end of the chapter exponents and the test paper. This will be test paper 5, and after that I will probably make another video to solve miscellaneous kinds of problems, which will be a little harder, covering all the variations of problems possible on this chapter exponents. so that we have a good grasp on the concepts of exponents and in solving and applying them in solving problems. So this is the idea. I hope this video was beneficial to you, and if it is, then please like it, share it with your friends. Once again, support me by subscribing to this channel, and also do not forget to press the bell icon so that you will be notified by my future videos. So thanks for watching, and until the next video, take care and bye.